Look up at the night sky. What do you see? Is it just a dark canvas dotted with tiny lights, or is it something more?
A dazzling tapestry of stars twinkles above us, each one a beacon of light in the vast expanse of space. Each point of light represents a distant sun, some similar to our own, others vastly different. Some are red giants, others are white dwarfs, and some are even neutron stars, the remnants of supernova explosions. These stars are not just points of light, they are massive, powerful entities, each with its own unique characteristics and life cycle. They are cosmic engines, forging the elements that make up everything we know. Through the process of nuclear fusion, stars create elements like carbon, oxygen, and iron, which are essential for life.
And some of these stars, the young ones, hold the potential for something truly extraordinary. The birth of new worlds and perhaps even life itself. These young stars are often found in nebulae, vast clouds of gas and dust where new stars are born. The universe is filled with these young stars, still in their infancy. They are the seeds of future solar systems, each with the potential to host planets and possibly life. They are surrounded by swirling clouds of gas and dust, the remnants of their formation. These clouds are the building blocks of planets, moons, and other celestial bodies.
These clouds, known as protoplanetary disks, are where planets are born. Over time, gravity pulls the gas and dust together, forming clumps that eventually become planets. Imagine a cosmic ballet with gravity pulling matter together, forming stars and their planetary systems. It's a delicate dance that has been choreographed by the laws of physics. It's a story that has been unfolding for billions of years, and it continues to this day. The universe is constantly evolving, with new stars being born and old stars dying.
From the smallest particles to the largest stars, the universe is interconnected. Every atom in our bodies was forged in the heart of a star, linking us to the cosmos in a profound way. And somewhere out there in the depths of space, another Earth-like planet may be orbiting a young star, waiting to be discovered. The search for these exoplanets is one of the most exciting frontiers in astronomy, offering the tantalizing possibility of finding life beyond our own planet. Astronomers around the world are using powerful telescopes to scan the skies, looking for signs of these distant worlds. Each discovery brings us one step closer to understanding our place in the universe. Imagine what it would be like to find another Earth, a world with oceans, mountains, and perhaps even life. It would be one of the greatest discoveries in human history, reshaping our understanding of the cosmos and our place within it. The universe is a vast and wondrous place, filled with mysteries waiting to be uncovered. From the birth of stars to the formation of planets, each discovery adds a new piece to the puzzle of our existence. So, the next time you look up at the night sky, remember that you are gazing at a universe of stars, each with its own story to tell. And who knows? One day, we may find that we are not alone in this vast cosmic expanse.
Stars are not scattered randomly across the cosmos. They are born in clusters, within vast clouds of gas and dust known as molecular clouds. These clouds are the nurseries of stars, the places where gravity gathers the raw materials for star formation.
Imagine a cloud so large that it dwarfs our entire solar system. A cold and dark expanse filled with hydrogen, helium, and traces of other elements. Within these clouds, pockets of gas and dust begin to clump together under the influence of gravity. As more material is drawn in, these clumps grow denser and hotter.
Over millions of years, the pressure and temperature at the core of these collapsing clouds reach a critical point. Hydrogen atoms, the simplest and most abundant element in the universe, begin to fuse together, releasing an incredible amount of energy. A star is born.
But the story doesn't end there. The birth of a star is just the beginning of a much larger cosmic drama.
The birth of a star is a chaotic and energetic event. It begins with the gravitational collapse of a dense region within a molecular cloud. As the gas and dust coalesce, the core temperature rises, eventually igniting nuclear fusion. The intense radiation from a newborn star blasts outwards, pushing against the surrounding gas and dust. This outward force creates shock waves that propagate through the cloud, compressing and heating the material further. This radiation also triggers chemical reactions within the cloud, transforming simple molecules into more complex ones. These reactions are driven by the energy provided by the star, which acts as a catalyst for the formation of new compounds.
It's like a cosmic kitchen. with the heat and energy of a star driving the creation of increasingly intricate chemical compounds. The swirling gas around the young star serves as a mixing bowl where elements combine in various ways. Among these compounds are the building blocks of life itself. Organic molecules like water, which is essential for all known forms of life. Water molecules form when hydrogen and oxygen atoms bond together in the cold regions of space. Methane, a simple hydrocarbon, and ammonia, a compound of nitrogen and hydrogen, are also formed in these cosmic environments. These molecules are crucial for the development of more complex organic chemistry.
These molecules are found throughout the universe, in molecular clouds, protoplanetary disks, and other regions where stars are born. Protoplanetary disks are particularly rich in these compounds, as they are the birthplaces of planets, and even on the surfaces of comets and asteroids. These small celestial bodies act as time capsules, preserving the chemical signatures of the early solar system. Their presence is a reminder that the ingredients for life are not unique to Earth. They are found in various locations across the galaxy, suggesting that the potential for life could exist elsewhere. They are scattered throughout the cosmos, waiting for the right conditions to come together. These conditions include the presence of liquid water, a stable environment, and a source of energy.
The formation of these organic molecules is a crucial step in the journey from simple star stuff to the complex chemistry of life. This process involves a series of chemical reactions that build upon each other, creating more and more complex molecules. It's a journey that takes us from the vastness of space to the microscopic world of molecules, highlighting the interconnectedness of the universe. Each step in this journey is a testament to the incredible processes that shape our cosmos. And it all begins in the hearts of stellar nurseries. These regions are the cradles of star formation, where the raw materials of the universe come together to create new stars and potentially new life.
Deep within the cold and dark recesses of molecular clouds, something remarkable happens.
The simple molecules formed in the aftermath of a star's birth begin to freeze onto tiny dust grains. These icy grains, coated in a layer of frozen water, methane, ammonia, and other organic molecules, become the seeds of planets.
Imagine a cosmic snowfall, with these icy grains clumping together like snowflakes. Over time, these clumps grow larger, forming larger objects known as planetesimals.
Planetesimals are the building blocks of planets, ranging in size from small asteroids to objects the size of our moon. The process of planet formation is a bit like building a snowman. It starts with small individual snowflakes which gradually stick together to form larger and larger snowballs.
In the chaotic environment of a protoplanetary disk, these planetesimals collide and merge, their gravity attracting more and more material. Over millions of years, these collisions and mergers give rise to planets, the diverse worlds that orbit stars throughout the universe.
Imagine a young star, blazing with energy, surrounded by a swirling disk of gas and dust. This is a protoplanetary disk, the birthplace of planets. These disks are the cradles of new worlds where the raw materials of the universe come together to form the building blocks of planets, moons, and other celestial bodies.
These disks are not just random collections of material. They are structured environments shaped by the interplay of gravity, rotation, and the intense radiation from the central star. The forces at play within these disks create intricate patterns and structures, guiding the formation of planets and other bodies. The gravity of the star pulls the material inward, while the rotation of the disk causes it to flatten and spread out, creating a thin, pancake-like structure.
Within these disks, different regions experience different temperatures and pressures. Close to the star, where temperatures are high, only rocky materials can survive. This is where rocky planets like Earth and Mars form. The intense heat causes lighter elements to evaporate, leaving behind heavier rocky materials that can withstand the extreme conditions. Over time, these rocky materials collide and stick together, gradually building up into larger and larger bodies.
Further out, beyond the frost line, temperatures are cold enough for ices to remain frozen. This is where gas giants like Jupiter and Saturn, and ice giants like Uranus and Neptune, form. In these colder regions, ices can accumulate and form the cores of these giant planets. The presence of ices allows these planets to grow much larger than their rocky counterparts, as they can capture and hold on to vast amounts of gas from the surrounding disk.
Protoplanetary disks are dynamic environments, constantly evolving as material accretes onto the central star and planets form within the disk. They are also relatively short-lived, lasting only a few million years before the remaining gas and dust is blown away by the star's radiation. During this time, the disk undergoes significant changes, with material being constantly redistributed and reprocessed. The interactions between the forming planets and the disk can create gaps and rings, further shaping the structure of the disk.
During this brief window of time, the stage is set for the formation of planetary systems, each with its own unique history and characteristics. The specific conditions within each disk, such as its composition, temperature, and density, play a crucial role in determining the types of planets that will form and their eventual arrangement. No two planetary systems are exactly alike, and the diversity of worlds that emerge from these disks is a testament to the complexity and beauty of the universe.